Thank you for watching my previous videos. In this video, I'm going to introduce the student t-test. I'll talk about the scheme for determining objectives or hypotheses that requires t-test, and lastly, we perform student t-test in R. The student's t-test is a statistical method. It is used to determine if there is a significant difference between the means of two groups or levels. It is a parametric test in that it is a test that follows an assumption or a distribution that we're going to discuss in the next slide. The types of t-tests we have are the unpaired or independent t-test. For unpaired or independent t-test, it is also known as a type of two-sample t-test that compares the means of two groups, and this group must be from two different populations. The next type of two-sample t-test is a paired sample t-test. This t-test compares means from same groups at different times. Say parameters taken from a particular population at different times. The next is the one sample t-test. The one sample t-test tests the means of a single group against a known mean, and this known mean is known as an hypothesized mean. So if the blood pressure of students in 200 level class is not above normal. So the scheme for choosing the right statistical test. Before you start the t-test for your data, you need to check if the data follows some assumptions, and this assumption is the fact that the data you have must be independent, in that they must not show any resemblance with each other, and the data must be gotten from an unbiased sample. Then the next is that the data must be normally distributed, and when data is normally distributed, it means the mean and median of that data is equal, and aside that, the plot of the data follows a bell-shaped or dumbbell-shaped curve. The third one is that the data must have equal variances, and the next is that the data must be quantitative, in that it must be measurable and it must also be continuous. And when you say data is continuous, it means the data, any value of the data must be able to lie in between two integers, meaning the data must be able to assume numbers with decimals. So after checking if your data follows these assumptions, you now need to consider the number of variables in your hypothesis. So for t-tests, you need to have two variables. You need to have one independent variable represented with one I, and one dependent variable represented with one D. So for t-test, within the independent variable, you need to have two groups or two levels. So when you have two groups, when you are comparing between means of two groups or two levels, it means you must use the t-test. So now we'll check some examples of hypotheses to know how to actually um, certify that a particular hypothesis requires the use of t-test. So the first one says there is no significant difference between the hematological parameters of control and extra treated group. First, you need to consider your dependent variable. Your dependent variable is the hematological parameters because they are variables that are measurable. Then the next one is to determine your independent variables. The independent variables are the control and the extra treated group. So this control and extra treated group will for sure have effect on the hematological parameters. That is what we are calling, that is why we named it independent variable. So aside the fact that we've been able to point out the dependent variable and independent variable, the next is to check, is your independent variable of two levels? Yes, for this hypothesis, my independent variables have two levels, the control and the extra treated group. The next is the next hypothesis is there is no seasonal variation in the phytochemical parameters of Macquarie Lake. The dependent variable in this hypothesis is the physicochemical parameters, while the independent variable is the seasonal variation. And we know in Nigeria or in Africa generally, we have two different seasons, the dry and rainy season. So if seasonal variation can be our independent variable, or if season can be our independent variable, and we say we have two seasons, then for sure this hypothesis will require the data to be run using t-test. The next is the blood pressure of 200 level students does not differ significantly from the standard values. So in this test, blood pressure blood pressure of the student will be our dependent variable and the standard value will be another variable, will be an hypothesized mean that I want to compare the value with. So this hypothesis will require a t-test. The next is the mathematics exam score of JSS3 and JSS2 does not differ significantly. The mathematics exam score here is the dependent variable, while the two different classes we have are the independent variable, and for sure the independent variable has two levels. So this hypothesis also requires the use of t-test. The last one is there is no significant difference in sales recorded for staff exposed to classroom training and online training. So in this hypothesis, the dependent variable that is measurable is the sales, while the different training, the classroom training and online training, are the independent variable.